Objective 12 is the Frost Tower website checkup, and it's a bit like the COVID-19 vaccine in that it may make you tired, and at the end of the day, you need SQL injections for it to work. Badum. Yeah, so that was a paraphrased joke from someone on Twitter. I can't remember who, and I'm not sure if it quite worked. But nonetheless, the challenge involves investigating Frost Tower's website for security issues. We're given the source code for the website, and we need to try and find Jack Frost's to-do list. This challenge is one of the 5 Christmas tree difficulty challenges this year, and it wound up taking me 6 to 7 hours to complete. The objective requires the following: find and bypass the logon screen. To be honest, before we go into more of what it requires, look, more time should have been spent reviewing the website code and flow of authentication events. It took me almost 3 hours just to get this one part right. Too much time spent trying to spin up a local version and connect to the database, which wasn't publicly facing. Words cannot even begin to explain the struggles faced in doing this one seemingly simple part of the challenge. I installed Express Session and Node. I tried to recreate and instantiate the MySQL database. There was random SQL injection attempts over and over and over. And there was much Googling. So much Googling. I may as well have been living in the Google matrix. I tried setting up my local session cookies to even match the secret sessions data found in server.js, and tried setting my session cookies and local storage to be literally anything else found in the scripts that were being checked, but none of this worked. Honestly, I felt pretty pathetic and stupid. We're at the 3-hour mark and I've not made any progress with the challenge. We'll touch on how this hurdle was passed in just a second, but let's go back to what the objective entails. After managing to bypass the logon screen, you're required to find a parameter vulnerable to SQL injection, or SQL injection I should say. Once the parameter is found, you'll need to formulate an SQL query, or SQL query, which will allow you to get data from other tables and join them in your results. Using this, you'll need to find and locate the name of a table called Todo, where you can just sort of guess it. And once this is done, you'll need to be able to extract the columns of to-do using a SQL injection without using any comma, as the application breaks any usage of a comma past a certain point where we're actually injecting into. Finally, using the note table names, you'll need to extract the note column from the to-do table and retrieve enough of these values to find out what job Jack is planning to offer Santa. As mentioned, this had a lot of wasted time, and so we'll try to skip over a lot of that, as it's not really fun watching me stumble around trying to run an application locally, and a lot of it has already been shown. What's that? You don't want me to skip over it? Right, well in that case, here's an hour worth of footage of me fumbling about. I've got this at 16 times speed, so it should only take about 3 to 4 minutes to complete. I hope you're happy. Now you need to listen to me rattle on about nothing. So, should you be studying or something instead of watching videos online? Oh, you are studying by watching this video to learn? Well, I feel for you, I truly do. If my rambling is helping you learn something, all hope is lost. Honestly, sometimes things seem difficult, but if you fumble around enough and steal enough content from the internet, you can sometimes succeed. I mean, always succeed. Yes, that one. Always succeed. So I may as well use this as a moment to defend all of my failures in this year's KringleCon. I truly did want to capture some of my failures in addition to solving the objectives, as most of the time you only see success. You don't generally see that someone has spent hours failing. hope this also helps to capture some of my thought processes with the challenges, some of the rabbit holes I fell down, and attempts which just plain weren't the right way to go about it. Stick with it, and you can succeed. I believe in you. Okay, so moving back into it, let's look at the moment when reviewing server.js that I had the answer on the tip of my tongue, but didn't realize it.
I want to know, is there a session equals request.session? So we've got this. To do with posting to a contact. I want to know if we can set request.session as something, or if that's ever done.
Pretty soon after, it hits me.
Already exists. This is posting to contact. Hold up. If you post to contact, it gives you a unique ID if it's already in the database. And your session is set to that email. Like your unique ID gets set to the email and you don't even need to authenticate. I think. Let's go to the contact us. Click save. This is email already exists, so this should have updated a unique ID, which you probably won't have here. Actually, we've got unique ID as 1 there, but I think that might have been something I stashed in there. But now if we go to dashboard, oh my god! Oh my god! Look at that floor! Holy moly! So the flaw in the server here is that if you try to post and contact them, it will check what you're sending, and if it already exists in the database, it will set a session with that particular unique ID, which is your email. Then because you've got that particular session stored and it knows that for you, you can just go to the dashboard, and the dashboard will be checking if you've got a session. So there is this what do we got? So if you do a get on this, it checks if you've got a unique ID from a session, which you do have just by simply doing that, and that allows you to get into the dashboard.
Honestly, this was a huge motivation booster and turning point to me in this challenge. I realized that the key to finding weaknesses here was actually in code review, not fuzzing, or in its technical term, throwing shit and hoping it sticks. I continued to review the code for the website and attempt to find injection opportunities. It seemed like every single instance where user input was occurring, the server would use an escape method to prevent SQL injection. One entry seemed a little bit different though. Whenever the application was requesting details from unique contact from the endpoint /detail/ID, it would take the input and split it with a comma. So long as one comma was present, it would do this and append to the query or ID equals, and then the next value split by a comma. Although this used escape also, it was specifying it on m.raw. Now, M was the connection to the MySQL database, so this was a raw connection to the MySQL database, and as such it ignored the command to escape, thus allowing me to perform injection on this parameter. I started out slow and tried to create a union query using some SQL injection cheat sheets. To be honest, I had to understand how a union query was going to work here. Basically, to do this, I had to understand that in order for a union query to work between two tables, it had to take in the same number and same type of data from both tables. This meant I had to know how many columns were present and what type of data they contained between two tables that I wanted to join. I started out basic to get it to parse multiple fields by just splitting them with a comma. I tried to select the version of MySQL in use, but this failed due to my injection query being pretty far off what it needed to be. I continued to fail for quite a bit of time, changing up the payloads. At one point, I even opened Burp Suite and tried to brute force this field with a number of SQL payloads taken from Payload Box's SQL injection payload list. As you may have guessed, this failed, and I needed to think more carefully about what I was doing. I was fairly confident that this was the injection point, but I had no idea how to exploit it properly. I was stuck. Again. I decided to focus my attention on union injections. There was a lot of fumbling around and not really understanding this type of injection attack. Eventually, a blog post from Portswigger, the company that makes Burp Suite, helped me out. I wanted to know how many columns were in this table, so I began ordering by a different number, increasing every single time. And I increased them till I got an error when I tried to order by 8. This told me that the table unique contact, which we were pulling data from, had 7 columns. I was going to perform the same on the users table as I wanted to extract password hashes and join them together, but then I realized where I'd been going wrong. Again. Code review. Say it with me. Code review. Because we have the inContactDB SQL command, we can actually see what database tables are created and the number of columns they have, in addition to what data they contain. Then I was determined to select only certain columns from unique contact or users and use a union to join them in my query to get the secret data from the users table. To specify certain tables only, I was going to use the null value for certain columns, as this is sort of ubiquitously allowed no matter what the data in the column. Although I encountered an issue. To do this, we require the use of commas, but commas are used to break up where we are injecting into. I tried resorting to join commands for a bit, but really didn't want to do this and it wasn't really working. At this point, I ran a Google search for how to perform MySQL injection without commas, and I found an entry on Hacktricks again. It turns out I had to combine a union query with a bunch of individual joins for different columns from tables. I didn't quite understand it even after going to the Stack Exchange post, which mentions how it is done. And so I did what any respecting security professional would do. I went to a different site until I found one that explained it and how I could use it in a way I understood, or at least understood how to do. In the end, I think I wound back on Hacktricks and tried it in my local MySQL instance setup a few times first. Probably one of the few things that this MySQL instance came in handy for. So yay me, it wasn't a complete waste of time spinning this up. My injection attempt stretched on for about an hour before I managed to get some syntax that worked to join data from the users table to our unique contact table. Don't underestimate this part of the challenge. This took an hour just to get some basic syntax right that I could use. I doubt throwing a tool like SQL Map at this would hand out the goods, so you need to actually understand what you're looking at and what you're doing. 5 minutes after this, I had password hashes for all the user accounts. It's a shame, but also good that these use bcrypt because it makes them difficult to crack, and at the end of the day, I don't think they needed to be cracked. From here, I wanted to change the users column to a column from a different table. The only issue is, I don't know what table to hit, and I don't know what columns it had. I began searching for ways to inject and bypass column name restrictions, but I didn't get too far before I thought that there must be another table I wasn't seeing. I began using my injection to try and figure out a table name. Invalid table names would give me an error, so I took a guess. So, can we do to do? We can do to do. So this to me is telling me that there is a table called to do. I tried extracting data from columns in the to do tables, even when they weren't known, but was having issues and just couldn't quite get the syntax correct. I wound up on SecGroup's GitHub page and I found their CTF write-up for Shire from 33C3, which as I know it is a German hacker convention. I ended up using select for the version within the MySQL query, which gave me the database version of 10.6.5 MariaDB. Then I wound up on another blog post by Perspective Risk, which had union commands selecting from the information schema table. I used concat to pull the schema name from the information schema table, and much to my surprise, it worked. Here I changed up my query to select column names where the table was to do. This gave me the names ID, note, and completed. From here, I was able to modify my previous injection command and select ID, note, and completed from the to-do table. I ensured this unioned on table columns within unique contacts that were likely to have the same data type, and this worked. It gave me a lot of to-do lists. Although they were broken up poorly and duplicated over many dot points, this wasn't a concern. Scrolling through, I found that Santa was to be offered a job as a clerk in the Frost Tower gift shop, so that Jack can keep an eye on him. And with that, I have somehow managed to stumble my way through this challenge and complete it. Fantastic. Praise be to Google.